All right, let's do it. Thank you so much, everyone, for joining us. Welcome. I hope you and your families are in good health and are in safety. We're so happy for you guys to join us on this repeated webinar because of popular demand. People really want to hear about this topic. It's very important in claims, claims investigations, and it is slightly technical, but Val does a great job at kind of breaking it down and giving us examples and stuff. So very excited to go through this again. So I just wanted to very quickly go through a couple of quick points with you with regards to the GoTo Webinar tool and everything. We're going to be doing a Q&A period at the very end of the webinar. So please feel free to submit your questions via the text box under the webinar screen there. I've actually put an arrow there for you to know precisely where to put that to submit questions. We're going to try to get to as many questions within the hour. If we don't get to your question in the webinar allotted time, we promise to follow up with you after the webinar and answer your questions by way of email. All the questions are going to be addressed anonymously. Unless you want a shout out, you can tell us to put in your name there. All information discussed in this webinar is for educational purposes only and should not be applied directly to the administration of any particular claim or file. We recommend that you reach out to us or any forensic engineer to kind of discuss the circumstances of a particular claim. And the webinar is being recorded and is going to be posted on our website, LinkedIn, and YouTube pages. So please feel free to pass them on to your colleagues or in team meetings. You're welcome to use them. We're also going to be sending out completion certificates probably mid next week. So we ask you to make sure that you're logged in under your own name. Like if you guys are in a group watching this together, make sure you log in separate accounts, or you can email us at webinar@origin-and-cause.com and just advise us of your name and your contact information, and we'll make sure that we get a completion certificate sent to you. Once the webinar is complete and you close the GoTo Webinar program, or the window at least, there's going to be a quick questionnaire that pops up with just a few questions asking you to rank the content and give us any feedback. We really love to hear from you guys. So if you could take 45 seconds to submit that questionnaire, we really appreciate that. All right, so let's hop right into it. So today, I'm very excited to have Vladimir join us today. He's also known as Val. Val is a branch manager and forensic engineer. He has written a chapter on fire investigation, specifically in the Lawyer's Guide to Forensic Sciences. It's a really cool chapter, and we're very honored to have Val join us today. His specialties include fire and explosion investigations, commercial and industrial machinery, equipment, and buildings. He is a board member and past national president of the Canadian Association of Fire Investigators. He's currently the training director at CAFI, and he also assists the Standard Council of Canada as a designated expert in their certifying body and the laboratory accreditation programs. So I'll pass off the mic to Val and we'll hop right into it.
Well, thank you very much, George, and welcome everybody. It's a pleasure to be back. So I'll quickly cover our outline of the presentation. It's a quick introduction to arc mapping, or what is arcing, and then we're going to step back a little bit and cover the 4 areas of information for origin determination, and then look at how arc mapping is part of that as a tool to help us in our fire investigations. And then we'll cover a couple of case studies and hopefully demonstrate how well that tool works. So first of all, what is arcing and what's arc mapping? Well, when arcing occurs, it can be seen as a flash of light, sparks, and spurting and such. And many of you have maybe seen it, whether it be in a movie or maybe experienced it when you were trying to boost a car battery, or maybe even when you crossed conductors and blew a couple of fuses. So the heat of an arc, internal heat of an arc is much higher than what you would see in a typical fire. So a typical fire is usually not going to cause damage to the wiring, but an arc will. Arcing has been measured, temperature of arcing has been measured to be 5,000 to 35,000 degrees Fahrenheit. That's within the arc itself. And that's more than the surface temperature of the sun. So you can imagine the kind of damage that it can cause. I mean, it's a very small area where that temperature is so high, but you can imagine the damage it causes. Now, as fire investigators at a fire scene, this is not what we're looking for. We're not looking for these bright lights and sparks and such. What we're looking for is that damage that I just mentioned, the damage to the wires that's left behind at the fire scene. And what does that look like? Well, here's the after effects of electrical arcing. You get small divots, you get beads of copper on the wires. These two wires have actually arc severed, and what happens, the amount of energy caused the wires to melt. You got this melted globule of copper on the end. And then if you look closely, actually, you see all these little these little divots and balls of copper on the wires. Each one of those represents an arc. So there was a lot of violent energy being expelled out of here, sparks and light and bright flashes. So this is the kind of damage we're, as investigators, looking for on the electrical wiring within a fire scene to help us establish an origin of the fire. So let's go back a little bit. Let's look at investigation methodology and how electrical arcing becomes a part of that toolbox. So terminology. So when we say we're doing a fire investigation, we're doing an origin and cause investigation. So and I specify origin is typically the first thing we do, and then cause comes afterwards. And this is because we need to find the origin of the fire, where the fire started, in order for us to find the cause. So origin is, you probably hear us talk about that in our reports, and that is the general location where the fire explosion began. Now, you may also hear us talk about area of origin. Now, that's defined as the structure or part of structure or general geographic location within the fire scene in which the point of origin of a fire or explosion is reasonably believed to have begun. So area of origin is sort of a general term that sort of says, yeah, the fire started in that part of the building. Now, point of origin. The point of origin is that the exact physical location within the area of origin where the heat source or the ignition source and the fuel interacted. So that and resulted in the fire or explosion. And it is at that point of origin that we would expect to find what the cause of that fire is, the ignition source and why the fire started. Now, the origin of, I'm going to stress that the origin of the fire is the most important hypothesis that an investigator develops and tests during the fire investigation. And this is because if you don't find the origin of the fire, you will not find the cause of the fire. And generally, if the correct origin is not identified, the subsequent cause determination will also be incorrect. So what are here's the 4 sources of information that we use to determine the origin of a fire. Witness information is really the analysis of the observations reported by persons who witnessed the fire or were aware of the conditions directly prior to the fire. Now, that could be through direct witness accounts, eyewitness observations, or it could be closed caption camera footage. And we see that more and more these days because so many more people are installing cameras and DVRs. Fire patterns, as we discussed, is the analysis of the effects and patterns left by the fire. And then we've got arc mapping. So arc mapping is the analysis of the locations where electrical arcing has caused that damage and the documentation of the involved electrical circuits. Now, the current version of NFPA 921, they've combined 3 and 2. So we really have 3 sources of information, but arc mapping has now become part of fire patterns because in essence, arc mapping is just another fire pattern. And then we have fire dynamics. And fire dynamics is really the physics and chemistry of fire initiation growth and the interaction between the fire and the building's systems. It could be anything like ventilation, the entrainment of oxygen, which will cause the fire to cause different fire patterns to develop. And we'll see a little bit that later. So let's look at the second category, some of the fire patterns. And so as I said, fire patterns leave damage on ceilings and walls and contents. In this case, we have a fire pattern on the wall, including the door, and I've drawn in the red lines that are kind of indicating what we call a V fire pattern. And in this case, the V, sometimes people say look for the ignition source at the base of the V. The V fire pattern, it could be pointing to the origin of the fire, or it could just be pointing to the location of a fuel package. There could have been some combustibles at the base of that V that have burned from fire spreading from another location in a room. In this case, if this is the only V pattern in the room and the rest of the room is undamaged, then you may have found the origin of the fire. Look at another one. So here we have a pretty well-defined fire pattern. We've got a V, another V fire pattern pointing to the side of the couch that's against the wall with the door. Sometimes when I'm presenting this to a live audience or in a live seminar, I'll ask the audience whether they think the door was open or closed during this fire. Think about that. When you look at that door, that fire pattern doesn't really stretch up along that door, does it? So I would say that door was probably open during the fire. That's why we don't have that defined burning up that door that would connect the fire patterns together. There's about 80 defined fire patterns, including the V fire pattern. V fire pattern is kind of the classic that people talk about, but yeah, there's 80 of them. Here's a photograph that's outlining the importance of fire dynamics and keeping that in mind when you're looking at the fire patterns and assessing where the fire started. So in this case, we see a lot of damage in this area. There's a lot of charring on some of the combustibles, but we have a point of ventilation. So this area is where a window was either open or breached or the glass broke, and it caused the entrainment of air into the room. In this case, this fire actually originated at the thimble to the wood stove in this area. And you can see that there's less so fire damage in this area and way more here. And that is the effects of ventilation on the fire. And that is why we need to consider fire dynamics as one of the sources of information as well. Now, this next sequence of slides, it's just a depiction. It's taken from the guy from NFPA 921, the Guide for Fire and Explosion Investigations. And I'm just going to illustrate how initially fire patterns are very useful, but when you get full room involvement, those fire patterns are going to be masked and they may actually be destroyed in the fire. So here you have a fire that starts on an upholstered chair in a corner of a room, say. And as the fire burns, it creates hot gases that rise and collect at the ceiling level. Those hot gases they start to descend, they start to spread along the ceiling until they hit an obstruction. And eventually they may pass that obstruction and those hot gases may spread to another room. Now, as the fire burns, air gets entrained into the room from any openings. It could be windows or doors. And this is where you get all your fire patterns formed. So if this fire was actually put out right now, you would see a plume fire pattern on the wall, or it may actually form a V fire pattern, and you're probably going to be able to find out where that fire started on the upholstered chair just by consumption and fire patterns alone. Now, let's say that fire continues to burn. It adds energy to the room. It adds energy to the heat layer or the smoke layer that collects at the top of the room. And eventually, as that smoke layer descends, that smoke layer is full of heat energy, and that heat energy is radiating down to all the combustibles in the room, preheating those combustibles. You still get that air entrainment into the room, which is providing the combustion air for that fire to continue to burn and generate hot gases and release of heat energy. Now, there's going to be a transition during the fire in the room. That transition, it's called full room involvement, or it's called flashover. And that's when the hot gas layer has descended to the point where it ignites all the other combustibles. And all the other combustibles ignite, they start to burn, and you're going to get all these other fire patterns being formed on the walls from these other fuel packages, all these other combustibles burning. This transition of full room involvement flashover, it's measured at about 590 Celsius in the room. So that's a pretty hot room. Okay, and at this point, the airflow, this past full room involvement and past flashover fires, all the combustibles are burning, and at this point, the fire transitions from being a fuel controlled fire to becoming a ventilation controlled fire. And what that means is we're not getting that air entrainment into the room anymore, where to where the fire originally started, and the fire goes out due to lack of air. So ergo ventilation controlled fire. The fire may spread out of the room and spread to other rooms, and you can see now that we have lost our initial fire pattern, and it's going to be much harder to actually determine the fire origin just based on fire patterns alone. So this is why, as fire investigators, so we need to have other tools in the tool chest. So this is what full room involvement or post flashover fire looks like. Now, this is where the fire was intense enough to burn everything in the room. Full room involvement will mask the initial fire patterns that would present a possible fire origin in the room. So what do we do in this case? Well, let's look at how arc mapping can help us in narrowing down the origin of the fire. So this is the Alcohol, Tobacco, Firearms, and Explosives Agency in the United States. They're a federal agency that is tasked with conducting fire investigations at the national level. They do a lot of research in fire science, and they put together this demonstration of a fuel cell to illustrate the usefulness of arc mapping. This is the top view of a burn cell, and they've set it up as a typical living room or bedroom in a house. So you got the outer walls of the house, you've got window, door openings, and here we have a couch, side table, and a coffee table with a ceiling light fixture in the center. Now, what they did, which is not typical to a typical living room is they set up a grid of energized wires at the ceiling level. So at the ceiling level, they spread wires, and each of these blocks represents circuit protection. So it could be a fuse or it could be a circuit breaker. And what they did was they set a fire on the couch. So this is the origin of the fire. And they watched what happens to the room, what happens to the electrical circuits that they've set up at the ceiling, and what kind of damage it causes on those electrical circuits. Now, each of the red dots represents areas where electrical arcing occurred on each of the circuits. And the electrical arcing, initially, once the wire gets attacked by the fire, the electrical arcing will trip the circuit protection. It will blow the fuse or open the breaker, and that damage from electrical arcing will stay on the wire. It's not going to spread, and it's not going to cause arcing anywhere else on the wire. So if you look at this, it actually forms sort of a pattern. Our origin of the fire is here. And if you look at the circuits, so there's east-west circuits and north-south circuits. If you were to draw an ellipse around, let's say, the north-south circuits, so blue ellipse represents the north-south circuits, all of the locations of arcing are in this half of the room. If you did the same with the east-west circuits, we draw an ellipse, and all the east-west circuits are through the center of the room, corresponding with the center of the room for the origin of the fire. Now, if you intersect those ellipses, that narrows your fire origin down to, I'd say, a fifth or a sixth of the room where the fire started. And this is without considering any fire patterns on the furniture or in the room. This is just by documenting the damage to the electrical circuits in the room. Now, this is a bit of an unrealistic case since most living rooms are not wired in a grid pattern, but this is just done to illustrate the usefulness of arc mapping. So let's look at some case studies and see how arc mapping can help us in origin determination. So here's a fire in a barn. There were no witnesses to tell us where the fire was first observed. And we can see by the fire patterns that greater fire damage is observed kind of towards the rear of the photograph. You can see the windows have been boarded up. So there's a lot of fire damage in this area, and from the perspective of the photographer, there's not a whole lot of fire damage that, the ceiling here or where the photographer is standing. Now, prior to my investigation, the local fire department had reached their own conclusion on the origin of the fire, and this is where they concluded that the fire started. So this is a rider type lawnmower. That's the seat in the lawnmower. I think that's a big tank at the back. There's a fuel tank there. And I mean, judging by the fire patterns, which indicated intense burning in this area, yeah, it's possibly an origin. There's some fire patterns on the floor here, which were probably caused by the intense burning of the seat or some other combustibles here. So it is possible. Here's another view of that same area. So that they're looking at this, it sort of forms a V. It's a V fire pattern. So could this be the fire origin? It could be. This is our lowest burning in the area. What about this area? We got some low burning here that appears to go kind of behind the fuel oil tank. And we see that we have some electrical wiring through the ceiling right here. And that wiring continues along here and then continues down and goes down to some area behind the tank. So we can actually utilize arc mapping in this case. So let's have a closer look here. So here's a closer look at the fuel fuel oil tank here. There's that arcing, sorry, there's that electrical cable, armor cable that comes down behind the tank. And we look at the top and we've got some electrical arcing going on. Now, part of arc mapping is documenting the electrical panel. So in this case, when the electrical panel was documented, the circuit that fed this cable was tripped. So we can assume that this arcing, or possibly another area of arcing on this branch circuit, caused the circuit breaker to trip and kind of freeze this fire pattern in time for us to look at. So what possibly created the fire? We look below this area of arcing and we see that armored cable actually feeds a couple of junction boxes, and there's something sticking out of that junction box. So taking a closer look at that, we cut that out and we have a look. And what we find is a clamshell electrical receptacle that's connected to another receptacle with wiring, and we trace that wiring to a sump pump that's outside of this area. And what we found was that there was an improper connection of the clamshell plug to the plug for the sump pump. It caused a poor electrical connection, resistive heating, and ignited this area, which spread the fire upwards and ignited the ceiling. So in this case, without the arc mapping exercise, we may actually end up concluding that the fire originated on the lawnmower and miss the low burning pattern for this area, which we've actually determined what the cause of the fire is. And do you think the fire department determined the cause of the fire at the lawnmower? Probably not. So let's look at another case study. So this is a residential fire. This is a bedroom that's that's an apartment over a retail location. This is what the fire scene looked like when I attended. This is after the fire department was in there. After the fire, they had suppressed the fire and then overhauled the fire scene, adjusting the location of the furniture. This is another view. The mattress is over here. This is looking to an exit door out of the bedroom, and we can see that the fire patterns are actually higher up on the wall. These upper fire patterns are actually formed by that ceiling layer, hot gas layer that I spoke about before. And we can see that's all kind of higher up than what we saw where that mattress was in the previous photograph. This is looking back towards the entry door into the bedroom. And again, you can see that hot gas layer caused some fire patterns on the walls. Not as low as where that mattress was located. So this is the view after excavation of the room and the fire debris. And we can see that the wall finish is actually made from plywood paneling. Plywood paneling burns pretty easily, so in this case, it's actually beneficial for us because the plywood paneling would have burnt away pretty quick in the fire and exposed some of this electrical branch circuit wiring for us to use in our arc mapping. And here you can see that we sort of have a V fire pattern, and it's pointing down probably towards some fuel, and possibly we might find a cause in this area. This area circled by the yellow circles is an electrical receptacle, a duplex receptacle. So it is right in the middle of our V fire pattern. So we're going to be interested in examining that. And here's 3 separate branch circuits that we're looking at for evidence of electrical arcing. So let's look at that receptacle. So receptacle actually looks pretty good. There's no apparent failures. Doesn't look like anything's plugged in right now. We don't know if there was anything plugged in before the fire. and you can see all the insulation has been burnt off the wires, and the wires, the copper wires from the electrical cables have been exposed. So we start by placing all the furniture back in its original location. Hopefully a witness may have help in placing the furniture back where it was prior to the fire. And we've got our friendly local fire chief that's helping us put the furniture back in its original location. This is actually the box spring, and we can see that the box spring, there's a bit of a bite out of it. Bite, I mean, it burnt away. And the yellow arrow is just pointing back to, as a reference, the location of that electrical receptacle, duplex receptacle. Now we continue in our fire scene reconstruction. We put the remains of the mattress. So this is the springs out of the mattress. You can see that all the stuffing and the wrap around the mattress has been burnt away, leaving behind just the springs. Again, that's where the location of the electrical receptacle is. And you can see that the fire patterns kind of correspond with the mattress being in this area, because when you look below the mattress, you've got less burning. Again, reference the duplex receptacle marked by the yellow arrow. And we put back the items that we found during our excavation and placed them back in their sort of general location where we found them. So a couple of the items we found a floor standing fan. So here's the base of it. Here's the cover off the fan, and the motor is actually encased in this area. This piece of fire debris is actually a plastic shelving unit that had various electronic components stored in it. There's some wiring from the fan itself that collapsed down on top of it. Now, any arc mapping exercise involves documenting the electrical panel. So in this case, we have a fuse panel, and during conducting our arc mapping survey, we have to check all the fuses and then trace the circuits back to our bedroom of origin to see which circuits we may have electrical arcing documented in. So this is a document from my notes. This is me documenting the fuses. The check marks indicate fuses that are continuous or not blown, and the X's indicate areas where the fuses have blown. I've got the ratings of the fuses as well, so it looks like somebody's been over fusing as well, because these are supposed to be all 15 amp fuses. I've marked the positions of where the fuses blew. Sometimes you get that off the guide in the fuse panel. In this case, some of that was mislabeled, so it took some physical tracing of the wiring and the use of tools to trace the wire. So we've got a hot water circuit, which is circuit number 8. We've got the kitchen lights, which is circuit number 6. And we have circuit number 5, the bath and bedroom. Now, it also helps drawing a diagram of the bedroom of origin. So this is a topographical view. You'll recall that's the bed in the corner. We had that bite out of the bed. And here's where our V fire pattern came down. There's a bathroom at the other side, and that's the entrance where we first stood to take a picture this way. Now, what's colored in yellow are the branch circuits that fed that bedroom, and the branch circuits that had arced. So here's that one branch circuit, and the red X actually indicates where we found electrical arcing. Here's the bath bedroom circuit. So we found electrical arcing here. That circuit actually went to that receptacle. This is a symbol of a receptacle when you're doing a diagram. that also spread to another receptacle here and to a light switch for the washroom. And then the heater, water heater circuit, it kind of went through the room and then went downstairs to the basement where the water heater was located. So again, we've got the locations of electrical arcing. Now, one would say, well, okay, good exercise, but you've got two areas of arcing here and one here. So which one indicates the origin? Well, so you have to take that in perspective. So let's have a look at the locations of the arcing here and here. So in this case, these two areas of arcing, we've got sort of where that area of bite mark was in that mattress, and I usually mark the areas of arcing with a orange ribbon, so we see that right here. So that sort of makes sense. If the fire started here, the mattress would burn, and then the hot gases of the fire would burn through the wall finish and then ignite the insulated wires and then cause electrical arcing in these areas. So what about this one over here? Well, we see that it's actually at the ceiling level, and it is at a sconce light fixture that's at the ceiling level. Here's the entrance into the room, and we have arcing at the area over here on the exposed wiring. So we can easily explain that because this area of arcing is actually at the ceiling level. As the fire builds, it forms that hot gas layer, and as that hot gas layer starts accumulating, it's full of heat energy, and just that heat energy in that hot gas layer cause that insulation to burn and cause that electrical arcing to trip that circuit protection. So easily explain that this is not origin location arcing, and that this likely is. Okay, so what does it look like? So if we look at the arcing in this area, this is what the arcing looks like. So you can see we've got divots out of the two wires, and we have actually copper transfer from here to here. So this is what we're looking for when we're looking for arc mapping. This is our evidence of arc mapping. Here's the other wire, that's the other circuit. So you can see there's a gouge and a transfer of material. So again, enormous amount of heat that caused arcing to occur and for the copper wires to melt and transfer. And this is what we're looking for. And we'll find that visually, but we'll also find that by running our fingers along the wires and finding the rough spots. So we continue our investigation. We found that piece of fire debris, which was the melted shelf, and we need to look in that wiring that's embedded in that plastic to see whether there's any other evidence of electrical arcing activity. And while we're looking at this, we actually flip it over and we find the remains of that electric motor for the oscillating fan that we found in that area of the bedroom. And we kind of do a quick evaluation. We see that the fan motor's actually got a lot of unmelted, it's melted plastic around it, but it actually didn't burn the plastic away. So that's, and you have some plastic on the shaft. So again, we're thinking probably fire was not caused by the electric fan, but we still need to look at the wiring. Some of the wiring is embedded in the plastic, so we need to somehow get access to it. There's no arcing evident on the exposed wiring, but and on the exposed, these are actually the power cord blades. Because the insulation burnt off, the blades have separated, but we don't see any arcing on the wiring, and we don't see any damage on the blades themselves. But we still want to make sure that we don't have any arcing embedded in that plastic material. So what do we have so far in this case? So we have a fire that started, we know in the location where it started, we've got electrical arcing. We later talked with the occupant. He reports to us that he did not smoke in the bedroom, only in the living room. The items in the plastic storage unit that burnt, he had a stored CB radio. He had miscellaneous power cords, wires, electrical components that were stored in that plastic cabinet. And the items plugged in the receptacle near the bed were a clock radio and the oscillating fan on a floor stand. So we haven't found the clock radio yet, so that's a possibility. We found the oscillating fan. So now with the reported information, what are possible causes? So we got smokers' materials. I call that a possible. A lot of smokers will admit to smoking, and they'll never admit to smoking in the area where the fire started. We've got candles. I didn't see any other candles in the apartment, so I didn't think that was likely. He also reported that he was not burning candles, didn't own any candles. Extension cords, not likely. We did find some extension cords, but they were outside of the origin area and they weren't damaged. And plugged in appliances or electrical items. So possible, not likely at this point, but we do want to have a closer look at that debris to see if there's any evidence of electrical arcing. So we take that debris back to our laboratory and we actually shoot some x-rays through it. Later on, we examine the x-rays. So this is actually the x-ray of that CB radio. We have a look at the circuitry. One way of telling in an x-ray whether there's any possible failure points is we look at splatter. We also look at dislocation of components. In this case, the circuit board's pretty intact. We see the components are typically in place. All the components are there. There's not a lot of evidence here. This is actually the clock radio. Again, this is a clearer view of some of the components that have not been displaced. And as I said, we look for splatter. So it looks like there's a bit of splatter here. You can see these dots that don't really belong there. But again, it's not really pointing to anything that's saying anything failed in this clock radio. And here's a couple of shots of that motor out of that fan. Again, you can see the winding, the motor winding over here, the motor shaft. Here's the bearings. The motor looks really good. It's not deformed. Again, we look for areas of splatter. When you look at the wires here, there's some dark areas which could be electrical arcing, but not likely. This X-ray actually didn't turn out that well because there's a big piece of metal in front, so the X-ray wasn't strong enough to shoot through. So we put all the evidence together and balance of probabilities. It doesn't look like we had any evidence of failure with any of the electrical items. Based on the arc mapping exercise, we established, along with the fire patterns agreed with our arc mapping exercise, and a decent conclusion may be that this fire is undetermined, or depending on which way the evidence points, it may be related to smokers' materials. So there are some limitations to arc mapping. I kind of pointed to what all the benefits are, and some of the benefits of arc mapping as well when you're examining appliances. When you find appliances, let's say you're doing an arc mapping exercise in a kitchen, you may find appliances that have been burnt. Let's say they're on a counter. And if you actually examine that appliance and the only area of electrical arcing you have is on the power cord to that appliance, you could safely say, or you could safely hypothesize that the fire spread to the appliance. Now, if you do examine that appliance and you found electrical arcing inside the appliance, let's say on a component or internal wiring, then you'll want to have a closer look at that appliance. Again, benefits of electrical arc mapping is you could do that on a much smaller scale with appliances. You can do it with vehicles as well. It's a big part of vehicle fire investigation in looking at the primary wiring connected to the battery between the alternator starter battery and the ECM, where you find and document the electrical arcing. You will probably be close to or in the area of origin. So as I said, there are limitations. Wiring located behind thermal barriers, let's say that wall finish was made from drywall. Drywall is going to take a lot longer to burn through for electrical arcing to be effective. So electrical arcing is good where we have exposed wiring, let's say in a basement with an open ceiling, or the ceiling fails early on in the fire. Wiring that only passes through certain areas of building, which sort of limits our information from wiring. So if, let's say, your fire origin was in an area that didn't have any wiring or didn't have a lot of wiring, then it kind of limits your ability to do a good arc mapping survey. And in total burns, when the building burns to the ground, you're going to have complete destruction of branch circuits, and you're going to have melting and separation of the wiring where it's not in its original location anymore, so it's not going to be very helpful. And sometimes you have backup generators or people energizing breakers after the fire, and that's going to cause arcing to happen in other areas of the building. Sometimes that happens with insureds or contractors going in after the fire, or even the fire department. They go in and they want to test the circuit, they flip the breaker, and then the breaker trips again, but again, it leaves that arcing damage on areas outside of that origin. So, and lastly, and most importantly, I would say, is the value of the information from arc mapping is directly dependent on the accuracy and the effort of correctly identifying the areas of arc sites. So if your investigator is ready and willing and spends the time in using that tool, it will usually be fruitful. Okay, well, that completes my presentation. And yes. George, we're at our Q&A.
Yes, thank you. Thank you, Val. So folks, if you have any questions, I know a few people have submitted questions. If you have any questions, make sure you do submit them now so that we make sure we get them answered. So first question, in the first burn cell, was the fire exposed or under sheetrock?
Are you talking about the ATF exercise? Is that what you're saying?
Here? I believe so.
Right.
It says the first burn cell.
Yeah, well, this burn cell is, the wires are all exposed, so there's no sheetrock there. They actually run the wires under the ceiling. And again, like I said, it's not representative of normal conditions in a typical residential house. So, but it is for the purpose of illustration of how we can use arc mapping. So really, it's not a realistic exercise, but just a point to how we can do it. And these wires are at the ceiling level, exposed underneath the ceiling.
Great.
Hopefully that answered that question.
Thank you, Val. For case study number 1, having decided that the clamshell connector is the more probable area or point of fire origin, can you further determine forensically if the internals of the clamshell connector had resulted in some kind of electrical fault that would have led to the heat source of the fire? How do you forensically do that?
So typically at a fire scene, if you find this you probably want to save that as evidence and take it back to the lab. At the lab, we can typically shoot X-rays through it and find areas of electrical arcing activity. And again, you're using arc mapping as your exercise. So your first failure would have been here, and the failure probably did not have enough energy to trip the circuit protection. The fire spread up to that area above over here, and finally the circuit protection activated. But in this case, when we take this back to the lab, this is a very defined failure point. You can see we got pretty undamaged plastic over here and totally destroyed plastic over here. So this sort of piques the interest of the investigator to look further. And typically what we'd find at the lab once we took all the char away is these wires actually came out of here, and you can see somebody hardwired them in, which again is not, it's poor code practice. You wouldn't do that. But what we'd probably find is areas of localized melting on these jaws that connect the male and the female clamshell receptacles together. So that's just to prove this is where the failure happened, and that resulted in the fire. Again, I'm not sure if I explained that properly, but hopefully if somebody has more questions, please go ahead and ask.
Sure. The next question is, for case study number 2, how long did it take you to trace the different branch circuits? What tools did you use to trace the wires to the respective fuses or breakers?
Right. Okay. So you can see the diagram. So drawing the diagram was part of it. Part of it was actually the panel. This is the bedroom. The kitchen was actually adjacent to the bedroom over here, and the panel was sort of in this area. So all these circuits went here. This one kind of came around and came back to the panel. So some tools that we use, it's called a circuit tracer. I don't have a handy picture of it here, but what you do is at the fuse panel or the circuit that you want to trace, let's say you want to trace it back to the panel, you have to find good wires. So you may cut the circuit where the wires actually become good again, and you attach what's called a toner. It's a little electronic device that injects a tone into the circuit, and then you go back to the electrical panel and you use a toner detector, and it's a little wand that beeps, and the beeping gets louder when you actually pass over the affected circuit. So that's one way of doing that. Now that's not 100%. If all your wires are shorted or are compromised somewhere else, that the tone is not going to get through to the panel. So you may actually have to do some physical tracing. In this case, we were actually able to do physical tracing because the ceiling fell down because there was a T-bar suspended ceiling, so we could actually physically and visually trace the cables back to the panel and kind of feel along. Sometimes you need ladders and feel along back to the panel, open the panel up and see what circuit it's connected to. So that becomes a bit laborious. And then in the areas of origin, you have to really, sometimes you don't know where to look, so you may have to go along a good section of that circuit, in this case, and then find this damage. And you're only going to find that, and you may find it in more than one location where there was secondary arcing because the first arcing didn't trip the circuit protection. But back to the original question, how long does it take, the exercise? So probably, I don't completely recall in this particular fire investigation, but I would probably maybe give it 2 hours, hour to 2 hours.
Okay.
To do that. So that's in addition to fire pattern analysis and such, but it really does give us a sort of a validation for the fire patterns we're seeing, the validation of a second set of evidence that still points to where we have hypothesized that the fire started.
Great, thank you. Next question. Really good presentation, Val. Thank you. Does the arc evidence or mapping change based on the material of the conductor, i.e. aluminum wiring?
Excellent question. Yes, it does. Aluminum has a much lower melting point, and aluminum will actually melt in a lot of fires. Typical fires, it won't, but it will get heat affected. So if you have aluminum wiring, you may not have as clear evidence of electrical arcing, because once the electrical arcing happens, then you've got other combustibles in the area that are burning, and they're going to actually radiate heat energy back to those aluminum conductors, and they may soften up this evidence, and they may make it look like just melting. So it is more difficult to do with aluminum wiring. It's much easier with copper, as copper doesn't typically melt in a standard fire. There's some fires where there's a lot of ventilation that copper will also melt, but it's like I said, it's more reliable with copper.
Okay, cool. We've got 6 questions and 5 minutes, so let's burn through them if we can, okay? Do you find it common for the generator to start after a fire begins and lead you in another direction or create illusion of multiple locations of origin?
Yes, yeah. So when a generator starts, it may energize a circuit that's been arced. Luckily, there's not a whole lot of fire investigations we do where generators are involved, so we don't have to deal with that as much. But yes, that's a valid point. When there is a generator available, we have to take that into account, and we see how the generator is wired. If the breaker's tripped, then maybe that generator is not feeding that circuit anymore anyway.
Okay, great. 2 questions about case study number 1. The first question is, which is the point of origin, the plug or the arc beaded sheathed cable? That's the first question.
Yeah.
The second question, the fire department determined the area of origin was at the lawnmower. What caused the fire pattern to show the low point of burning in this area? Drop down? With the wire, what caused the extension of the fire up the concrete wall?
Okay, so I'll go back to the first question. So 2 possible origin areas, one here, or not possible, two identified origin areas, fire department here, mine was here. The fire origin is actually where the failure happened at that plug down here, not up here. This is just an effect of the fire spreading up from this area, right? So I mean, the wire could have arced here, but it arced here, probably because there was a bit of a sealing. You can see that there's a bit of a protection pattern here. So I think we have plywood on the ceiling. So as the fire burned, those hot gases, remember the ceiling layer collected up here, and the presence of those hot gases caused that failure of that electrical cable here, resulting in electrical arcing.
Well, that also relates to another question we received. How do you differentiate what you observe on the electrical cable is because of arcing or melted due to the fire?
Right. Well, that's the quandary of the fire investigator. So again, you have to take everything into perspective, and the question always is it causal arcing or is it origin arcing or effect arcing? And you have to look at it in context. You find arcing here, and you kind of look at the location, and if you didn't find anything down here, maybe there was no burning here, all the burning was up here, you may conclude maybe that this wire was pinched, and that's where the arcing happened, because it was causal arcing. The arcing was caused as a result of the wire being pinched and severed. Now, because I continued down and looked here and found an obvious failure at that clamshell connector, and it's downstream on that wire, then that points to here and points to this as being fire spread arcing.
Cool.
As far as, there was that other question about the fire department concluding this being the origin.
Mhm.
Again, it could be a combination. It could be the charred ceiling here and drop down, like somebody mentioned. It could be drop down materials igniting the seep, but it may also be, you can see the ceiling layer along here. It's about this high, so that's getting kind of low here. So if you recall that ceiling layer from a fire that's burning and accumulating, it's radiating down, and the seat's going to be a pretty easy ignition. It's going to be easily ignited from the hot ceiling layer. You've got the vinyl on the seat and the foam and stuff. You can see some of that fire effect damage here as well from the ceiling layer. You can see some of the melting, the shelf. So, you know, they're just looking down at the lowest burning, but really, yeah. So this area might be dropped down or another fuel package.
Cool. Let's squeeze in one more question, and then the balance of them we promise to answer by email. Have you ever seen in poor wiring installations where someone has combined aluminum wiring and copper wiring? Can you still have arc effects left?
Yeah, I've seen it where people have connected copper and aluminum wiring. I mean, there is the proper way of doing it, and there's the improper. Sometimes you do get arcing in that area, and the arc just due to you're going to get poor resistive connections at that point if it's not done properly. And those poor resistive connections are going to result in electrical arcing and possibly ignition of nearby combustibles. And you will see that in the evidence of arcing evidence, like those divots and balls on the copper wires, and probably melted away aluminum wires. And it may happen on just maybe one of the wires, because you'll typically have more than one wire connected copper to aluminum in a junction box or in a circuit.
Cool.
Hopefully that answered that question.
Great. Well, thank you so much, Val, for your time, and thank you all for joining us. Sorry, we're 1 minute late, but we thank you all for participating. I'm seeing a lot of questions coming in, and folks just saying thank you. Great presentation. So thank you again, Val. Thank you all for joining us. I hope you have a safe afternoon, and hope to catch you in our next webinar.
Thank you all.
Have a great day, everyone.